Okay, then I'm going to show you real quick the last method, and that method is called quadratic formula. I'll start by reminding you that quadratic equation in standard form has this form: ax squared plus bx plus c equals 0, where a, b, and c are just some numbers. And the way you solve a quadratic equation using quadratic formula is you take the following formula and you basically throw all the numbers in that formula and simplify, and you get your solutions. But the formula itself looks a bit intimidating, but if you have it in front of you, then it's not that bad. So let me write down negative b plus or minus, well, that same plus and minus that we always end up with everywhere when we solve quadratic equations. Square root of b squared minus 4ac, meaning that minus 4 times a times c, and that's all inside the square root, divided by or over 2 times a. Okay, that's how quadratic formula looks like. And as I said, it has a lot of things going on, but if it's in front of you, then what you have to do is just simply take a, b, and c, throw those numbers into the formula, so replace each value or each letter with the right number, and then simplify, and you will end up with a solution. So the first example, x squared minus 10x plus 16 equals 0. Okay, so you start by writing a, b, and c. So what is a, what is b, and what is c? So you guys help me. What is a? 1. How about b? Negative 10, right? And c, 16. Okay, I'll help you with this one. c, 16. C, 16. Okay, so you determine a, b, and c. And as I said, you just put them into the formula. Just be careful. Let's see how it's going to look like. X equals. Now, in the formula, it says negative b. So formula has negative sign. So I'm going to put it here. Here's that negative from the formula. But then b itself is also negative, right? So negative, the first negative is from the formula, and then second negative comes with b. So that's b. Right? So hopefully it makes sense. If it's not, just stop me and I'll re-explain. But yeah, first negative for the formula, from the formula, second negative comes with b itself. So we have two minuses, which we'll later simplify. Okay, so then plus and minus, I'm following the formula. Then according to the formula, I have to say inside the square root, b squared. Since b is always squared according to the formula, I have to be careful, especially when it's a negative number. Make sure that you enclose it into the parentheses. So it's negative 10, that's b, and the whole thing is squared because you want to square both number and the sign. So everything gets squared or multiplied by itself. Then minus 4ac means that I have to take 4, multiply by a, that's 1, and then multiply by c, that's 16. And then I put, and that's all inside the square root, then I put fraction bar, which stretches all the way. It's like super long. Make sure that it kind of goes all the way. In the denominator, it's 2 times a. A is 1. Then after that, you just have to carefully simplify. Now, outside, if you have 2 negatives, well, then replace them with plus. So it's positive 10, plus and minus. And then inside the square root, you have to, also take your time to simplify. Just make sure you follow the order of operations. Remember, according to the order of operations, first we do the square. So we'll square negative 10. It's negative 10 times negative 10, so that's 100, positive 100. So that number will always end up being positive, right? And then according to order of operations, so we do power, and then we do multiplication before we do subtraction. So this subtraction will always be, or this sign in the middle will always be like the very last step. So 4 times 1 gives me a 4, and then 4 times 16, 64. Yeah, 40 plus 24, 64. Thank you. Minus 64. That's all those three together. And then denominator is just 2 times 1, which is 2. Okay, now I'm going to come back to the denominator, not denominator, to the square root. So it's 10 plus or minus. Inside the square root, I have 100 minus 64. That's 36. still over 2. And now at this point, so once you simplify everything, so once you simplify radical down to just one number, well, that's where you're going to have different cases. Now, we started with like the easiest case, because square root of 36, I can easily evaluate, right? That's 6. But you can have other cases. You can have case where that number is not a perfect square. You just have to try to pull something out of that square, simplifying the radical. That's our old topic. Or you may also have negative number inside the square root. That means that you're going to end up with a complex number, right? It's going to be I. So all that little algebra that we already learned so far, you will be using here, but just keep in mind that, well, these are possible options. You can have something nice like we got here, or you're going to end up, a radical will not go away, or you may even end up with a complex number. So these are all the possibilities. But this time it's 10 plus or minus 6 over 2. Okay, and since we ended up with numbers that we can add together, right, 10 and 6 or minus 6, I can easily combine. So radical I would not be able to combine, but 10 and 6 I can. That's going to be a good spot to separating those two plus and minus signs. So from here, I will go to kind of one direction with plus. So it's 10 plus 6 over 2. I will evaluate that. And then I will do 10 minus 6 over 2. And I will evaluate that. And then we'll produce two solutions. So 10 plus 6 is 16 over 2. And that is 8. And then 10 minus 6 is 4 over 2. That is 2. It's also common to end up with fractions here. So I got like super nice example. But it's also possible that at the end fractions will not simplify, so like completely divide, so you will end up with fractions, which is totally fine. So just go with the flow here, just be careful. Okay, but we'll go a little bit quicker. So let's do m squared plus m plus 2. I'm changing that from, to m from x. It's still quadratic equation because of the second power, and we're going to be using quadratic formula. Even though I'm using m, a, b, and c are the same, kind of at the same spots. So you start by listing a, b, and c. So what is a?
1.
1. How about b?
1.
1. And c? 2. That's right. Perfect. Okay. And now, as you have a, b, and c in front of you, and then you just throw everything into the quadratic formula. It's up there. I want you kind of to follow as we write that. Okay, so it's negative b. Negative comes from the formula. Here it's negative from the formula, and then b itself in our case is 1. So right away I'll just get negative 1. See, I don't have that double sign anymore in this case. Plus or minus, it's always there. Inside the square root, I have b squared. Now it's positive 1. I don't have to use parentheses. Probably to develop a habit of just writing it just in case. Keep writing it, even if it's a positive number. So 1 squared minus 4 times a is 1, times c, that's 2. That's all inside the square root. Long fraction bar. Make sure that you write long enough so everything square root is also on the top. And then in the denominator, it's 2 times a. A is 1, 2 times 1, like that. Okay, so that's just putting all the numbers into the formula. And let's simplify. So negative 1 stays as negative 1, plus or minus. Now let's work on the radical. Inside the radical, I have 1 squared. Well, 1 squared is 1. Then before I apply that subtraction, I have to perform multiplication. So subtraction is the very last step. Multiplication is 4 times 1, and then times 2, that's just 8. Minus 8. Divided by 2. Okay, so that is negative 1 plus or minus. So what do I get inside the radical this time? 1 minus 8. Make sure that you follow the order of numbers. 1 minus 8. Smaller number minus larger number. It's going to be always something negative. So it's negative 7. Negative 7 over 2. And when you have something negative inside the square root, we know that we're going to end up with a complex number, right? So negative 1 stays like that, plus or minus. Now that negative, I'm gonna kind of pull out of that negative, pull out of that radical sign, and it will be I. it will appear as I, the imaginary unit outside of the radical. And now I only have 7 that's left. Well, can I split up 7 in any convenient way? No, 7 is a prime number, right? So there's nothing I can do with it to simplify or pull anything outside of the radical. So 7 cannot be split up. So it has to stay, all of that has to stay inside the radical. So negative I kind of pulled out, that became I, but then 7 itself stays inside the radical like that. And then I have 2 in the denominator. So that's how we simplify it. And now when you end up with a complex number as the result, you know, of the quadratic formula or any time, remember that complex numbers, they have to be in a special form. It cannot be one fraction. It always has to be separated into 2 parts, a real part. So yeah, real part and an imaginary part. And to show it here, I'll divide that 2 into each part of the numerator like that. So I will split the number this way. So the real part will be negative 1/2. And then I'll keep this as plus and minus. And now the second part, the imaginary part, is I squared of 7 over 2. So it's good to always put things in front of the square root, variables, numbers, or I, so that doesn't look like it, you know, accidentally gets inside the square root. So here it's like clear that it's outside. Yeah, like that. And that's the answer. These are 2 solutions of that equation. Most likely on ALEKS, you will have to list them in order. Well, not necessarily in order. So there is no order to solutions. I mean, there's no defined order. So you can write them in any order you want, but list them. So if you decide to list them, they're going to be those 2 solutions. Negative 1/2 plus I squared of 7 over 2. That's the first solution. And then negative 1/2 minus I squared of 7 over 2. That's going to be the second solution, one with plus and one with minus. Okay, now the last example, I will show you, or we'll need to solve this in this form. So x squared equals 2 minus 4x. I'm just going to show you kind of a special case, so that just in case if it happens, you get like that, get it on the homework, you know what to do. Now, is this a quadratic equation? Well, yes, it is, because it has x squared, right? And it's the highest power. It's quadratic. And we're doing quadratic formula here. But we know that for quadratic formula, we need to know A, B, and C, right? Now, what is unusual about this example? Well, unusual is that terms are on both sides of the equation, right? And if you're using quadratic formula and it happens that you don't have all terms on one side, well, you need to start by putting all terms on one side and creating 0 on the other side. So that's all it is. I mean, there's really, I said it's a special case, but there's not that much special to it. Just know that if there's no 0 on one side, well, create 0 on one side. So let's collect all terms on one side. Let's say on the left-hand side, or same side where we have x squared. I'll say make 0. To make 0, I have to get rid of 2. Well, if it's positive 2, to get rid of positive 2, I need to subtract 2. So minus 2. Well, it means that I'll have to do minus 2 on the left as well to keep it balanced. Now 2 is gone. Next, I also have minus 4x. If I want to get rid of minus 4x, I have to add 4x. It's negative 4x plus 4x, they also cancel each other out. Well, if I add 4x on the right, I have to add 4x on the left. Well, now I can see how on the right-hand side it's 0. And what is on the left-hand side? Now, on the left-hand side, I have a bunch of terms, but none of them are like terms, right? They're all unlike terms. X squared, just number 2, and then 4x. They're all unlike terms, so I'm going to be writing them in order. So to determine A, B, and C, it's also important to write terms in the right order so that you don't confuse yourself. So we start with the highest power, x squared. Then we're going to place the x term, so it's plus 4x, and then minus 2, like that. And after that, we kind of know what to do, right? So A is 1, B is 4, C is negative 2. So let's throw everything into quadratic formula. It's negative b from the formula. So negative from the formula, b is just 4. That formula has plus or minus, or plus and minus, then square root. Inside the square root, I have b squared, so that means that I have to square 4, minus from the formula 4 from the formula, that 4 is always there, times a, that's 1, and then times b, that's 4. And all that over 2 from the formula times a is 1.
Is it 4ac?
4 times, oh yeah, okay.
Going to be negative 2 at the end.
No, very good. I was just checking if you're listening. Very good. Thank you for catching that. So it's 4 times a times c, and then c is negative 2. Yeah, that was a mistake. 4 times a times c, like that. Perfect. Now that should be right. So now inside the square root we have, well, 4 squared, that's 16. And then, you know, the minus, I said we do it at the end, but see what happens now when we start multiplying. So it's, let me ask you, how would you write this? So how would you write everything after 16? What would you write? There are kind of a couple ways to write this. I'm wondering what your brain tells you to write. Okay.
The one you just kind of forget about.
Right. Okay. So you would write negative 4 times negative 2, like that, right?
Yeah.
Okay. And then, so let's go back to that square root. Then what would you write next inside the square root?
16 plus 8.
Okay. Yeah, that's, I think I would write it the same way. So that minus sign, you can either think about it as minus sign, or you kind of can combine it with 4, right? You can treat it as negative 4. And if you do negative 4 times negative 2, it's going to be positive 8. Well, I mean, there's still 16 is still separated from the result. So it's going to be 16 plus 8, like that. That's what we have, and divide by 2. So negative 4 plus or minus 16 plus 8, 24, right? 24, that's right, over 2. And now here's our, like, kind of the third case where number is positive inside the square root, so we will not get any complex numbers. However, 24 is not a perfect square, right? We can't just evaluate 24. The only thing we can try is to simplify square root of 24, like pull something out of square root of 24. We have a couple techniques to do that. Since 24 is, you know, not that large, it's a kind of convenient number to work with. So we may just think about it as a product of something that's good to take square root of and something else. So how do we split 24? I think we already had 24 today. Square root of 24. I feel like it was in one of the examples. So what would be the good way to split up 24?
2 square root of 3. Oh.
Yeah, so that's going to be 2 squared. So basically, it's 4 times 6, right?
Yes.
4 times 6. Okay, and then square root of 4. We can evaluate. That's going to be 2. That's just 2. But then 6 will stay inside the radical. So that means that it's negative 4 plus or minus 2 square root of 6 over 2, like that. Let me know if you catch any mistakes. But if that looks right, then at this point, the last thing that we can consider is we don't really have to split things up. So we have options. One option is to split things up same way as we split them for complex numbers. It's like, you know, kind of put that over 2 underneath each term of the numerator. Or if we want to keep it all as one fraction, and then in this case we can. It's not a complex number, so we can totally keep this all together as one. We can still try to simplify it, but we talked about it at some point. And when we had some notation, and actually it was example with radicals, we said that if you decide to simplify, divide out a common factor, either you divide that number out of all terms or none of them. So here we have 4, 2 square root of 6, and 2. So if you can find something that divides all of them, then you can simplify without splitting the number. And in this case, we can't find it, right? So both 4, 2, and 2 can be divided by 2. So see how I can divide all of them by 2? Well, then I can go ahead and divide. I cannot just pick only 2 of them out of 3. So it's either all 3 or none. So it's going to be 2 here, 1, and then 1. Well, 1 in the denominator I don't have to write. So it's going to be -2 plus or minus. And actually 1 in front of the radical I also don't have to write. I can just drop that. So it's going to be simply square root of 6. And these are the two solutions. We cannot really add -2 and square root of 6. We can just keep them, or subtract. We can just, we're going to keep them, in this form. But these are two solutions to that equation. On Alex, if you need to, and most likely you need to list them separately, then you'll say -2 plus square root of 6. That's first solution. And then -2 minus square root of 6. That's going to be the second solution.